Right. So as you are with you guys in class and those of us joining in, watching at home, make sure that you have out your notes and that extra sheet every day. So make sure you got that extra sheet out also, because we'll be adding another line to that sheet today, and then using that going forward. Okay?
How many steps are
There's going to be 8 total. So you probably only needed like 1 or 2 lines for step 0, and then step 1 is find the domain and for vertical asymptotes. So some of them need more space, other ones just are a quick little line. So, all right. So next one that we're going to have, or the next, it's actually going to end up being the next step on what we do. But the next step on our journey to graph these wonderful functions is we need to find the horizontal asymptote. Okay? So a couple of things first about the horizontal asymptote. Okay? First off, it is also, just like a vertical asymptote, it is a line, so it needs to be in the form now of y equals some number. Just telling me the number is not good enough, okay? Because it needs to be in line form, because it is a line. It's not a number. Okay? So it needs to be in that y equals some number form, because all horizontal lines are y equals lines. It will also go on your graph as a dashed line. Okay? The nice thing about finding a horizontal asymptote is it is tied. Why all of a sudden just give me a little pause for the call there. It ties in with the end behavior. Because it is what your function approaches at the infinities. Okay? So as we get farther and farther to the left and farther to the right on our functions, our graph, or the function, is going to approach this horizontal asymptote at the extremes, at the left and right side of our graph. Okay? The other nice thing is that because it's a horizontal asymptote, with vertical asymptotes we could have as many as we want. But with horizontal asymptotes, we're either going to have one or none. We just have to figure out how we can get that, if it's going to be one of them and what it's going to be, or if it's going to be none of them, or none aspect. Okay? So how do we do that? Well, let's figure it out right now. Okay? It's actually relatively easy. We look at the degrees of the numerator and denominator. So the degree, remember, is the biggest exponent. So you're looking at the biggest exponent on the top, and you're comparing it to the biggest exponent on the bottom. Okay? So if the top is bigger, okay, so it would be like a big over small case would be another way of comparing them. Okay? So the top one is bigger. There is no horizontal asymptote. That's our none case. Okay? If the top degree, top exponent is bigger than the bottom, or the numerator exponent, or not, easy for me to say. If the numerator's degree is bigger than the denominator's degree, then there's none. If the bottom is bigger than the top, so that would be a small over big case in terms of degrees, which is what we've been dealing with so far. We've been dealing with so far where the numerator's exponent has been 0 and the denominator's exponent has been 1 or 2. Okay? We're in a small over big case. That's going to be y equals 0 is our horizontal asymptote, which is just the x-axis. This bottom one is the one that I don't want to say the most confusing, but it's the one where you have to do some thinking. When those two exponents are the same, okay? When they're the same, then we have to look at, or our horizontal asymptote is the line y equals a over b. And we get the a and the b from our function. Actually, this would be n also because they would be the same. And that a and that b are the lead coefficients. Of both the numerator and the denominator. Because those x values kind of cancel each other out. Okay. And that's how we find our horizontal asymptotes. So, if we go to our cheat sheet, okay, your extra sheet now, okay, so we're still saving some space for step 0. Okay, we'll get there. We're not quite there yet. Okay. Step number 1 was what you got from Monday. Find the domain and find any vertical asymptotes. And we do that by setting the denominator equal to 0, solving it. That gets us the restrictions for the domain, and it gets us our vertical asymptotes. Okay. Step 2, then, is going to be finding the horizontal asymptote. And we've got 3 possible scenarios there. If it's big over small in terms of degrees, big over small, none. Small over big, y equals 0. If it's the same, y equals a over b, and a over b, or a and b come from the lead coefficients of our numerator and denominator. Those of you at home, you can pause and get that written down. All right, so 2 examples here. It says find the domain of the function and identify any horizontal and vertical asymptotes. Okay. So first we have to find the domain. So we take our denominator. Our denominator was x plus 1. We set that equal to 0. And so then that's going to give us x equals negative 1. Agree? So that's going to tell us that our domain is all real numbers, but x cannot equal negative 1. Agree? Yeah. Tells me that my vertical asymptote then is x equals negative 1. Sorry, OCD kicked in, had to get the right color. Okay? Then, to find our horizontal asymptote, we compare the degrees. So up top, the degree is 2. On the bottom, the degree is 1. So this is a big over small case. Or top is bigger than the bottom case. So there is no horizontal asymptote. So we would just write no. We can't write 0, because 0 is a number. We can't write y equals 0, because y equals 0 means that there would be one. There just isn't one in this case. Okay? What I want you guys to do now is try example number 2. Same thing. Find me the domain, find me the vertical asymptote, find me the horizontal asymptote. So, x squared minus 9 equals 0. X squared equals 9. So x equals plus or minus 3 when I square root both sides. So my domain then is all real numbers, with the exception of x cannot equal plus or minus 3. So that would give me vertical asymptotes at x equals negative 3 and x equals positive 3. Agree? Okay. This particular function has a exponent of 2 on the top and an exponent of 2 on the bottom. A little too small. 2 on the bottom, 2 on the top. So that's the same case. So then I have to look at lead coefficients. So down here, there's a lead coefficient of 1. So it's my horizontal asymptote then would be y equals 6. If you put 6 over 1, that's fine. But on a test or something like that, I'd want to just y equals 6. So here's our function. We want to find the domain. We want to identify any horizontal and vertical asymptotes. And then let's bring in end behavior and asymptotal behavior too into play. Okay? So, first off, we got to take the numerator, or excuse me, the denominator, x minus 2 on the cube, and we're going to set that equal to 0. I'm first going to take the cube root of both sides. Cube root of the left side is just going to be x minus 2. Cube root of 0, what times itself 3 times is 0? Well, that's just going to be 0. So then I get x here equals 2 as my one restriction. So my domain would be all real numbers, but x cannot equal 2. If that's the case, what's my vertical asymptote? X equals 2. Yep. Okay. On the top, we have a degree of 1. There's a 1 attached to that variable. On the bottom, we have a degree of 3. So that is a small over big case, which would mean that my horizontal asymptote, according to my cheat sheet, is what? Y equals 0. 11. Yeah. So then we've got end behavior and asymptotal behavior to go. So my end behavior is going to be as x approaches positive infinity, my function is going to approach 0 because 0 is my horizontal asymptote. Okay? These two numbers are going to always be the same. We just got to figure out if it's approaching from above or from below. Yeah? But we know that it's going to be like in this form. Yeah? So if I put in a really huge positive number, I'm going to end up with a positive number on top, because 4 times that really huge number is still going to be positive. And I'm going to end up with a positive number on the bottom. Correct? Okay. So that tells me then that I am going positive by a positive that's going to approach from above. Agree? Okay. If I put in a really huge, or I shouldn't say really huge, a really small negative number. So now let's go to negative infinity. I put that in on top, I'm going to multiply that by 4. That's going to be still negative, right? Negative 1,000,000 times 4 is negative 4,000,000. Okay? If I put in a negative number on the bottom, I'm going to subtract 2 more first, so it's still going to be negative, and then I'm going to cube it. So a negative times a negative times a negative is negative or positive? It's still negative. So I got a negative divided by a negative. And a negative divided by a negative is positive. So this one actually approaches 0 from above on both sides. Okay. And then lastly, you just have to figure out our asymptotal behavior. So now we're going to say, as x approaches 2 from the left, f of x is going to go somewhere. And as x approaches 2 from the right, f of x is going to go somewhere. Okay. So if I go from the left, so give me a number on the left side of 2. 1. Okay, so let's go like 1.9. Okay, because then we're a little bit closer. Okay, so let's do 1.9. So if I put 1.9 in there, on top, 1.9 times 4 is still going to be positive, right? Positive times positive, still positive. Okay? On the bottom, 1.9 minus 2. That's negative, right? And negative cubed is a negative, correct? So positive divided by the negative is negative, so this is going to go to negative infinity. Asymptotal behavior is always going to go to infinities. We just got to figure out if it's positive or negative. End behavior is always going to go to the horizontal asymptote. We just got to figure if it's above or below. Okay? Let's flip it over to the other side. Let's go 2.1. 2.1 is positive. Multiply it by 4. Still positive. 2.1 minus 2 now, that's positive, right? Positive 0.1. And I cube a positive number, still going to be positive, right? Positive divided by a positive is a positive, so this side is going to positive. Okay? And that is all of the things that were asked of us. Divine. Love it. Yeah. What I'd like you to do now is I'd like you to try one on your own. Try this one. Find, again, domain, vertical asymptote, horizontal asymptote, end behavior, and asymptotal behavior. For those of you at home, this is an additional example that I put into the notes. Sorry I didn't update the daily notes sheet, but I literally put it in a half an hour ago. Alright, so x is equal to 0, so x is equal to 3. Right? So that tells me that my domain is all real numbers, but x cannot be 3, which tells me that I have a vertical asymptote at x equals 3. Agree? Yeah. The degree, or I should say the degree on top is 1. The degree on the bottom is 1. So those are the same. So I have to go with lead coefficients then. So my lead coefficients would be right there. So my horizontal asymptote is y equals 2. So my end behavior would be as x approaches positive infinity, f of x is going to 2. I just don't know if it's above or below yet. And as x is going to negative infinity, f of x is going to 2 also. Got to figure out above or below. Yeah. So let's go back and let's figure out above and below here. So if I am going to positive infinity, on top I would have a positive number. Positive infinity times 2 is still positive, plus 4 is still positive. Okay. On the bottom, I would have positive infinity minus 3 is still positive. So that would be going above or below. But now we got to think, because now it's not just positive and negative. So I can't just do that way anymore. So what we kind of got to do is we got to say, all right, well, on top it's like twice as big, okay? And so it's bigger, and so I would say that the top would go from above, right? Because of the fact that if I get out to some big numbers, okay? So because we're not at 0, we can't necessarily do this anymore. Right? Well, that's fine. So let's think of, like, if we were at 1,000. On the top, we'd have 2004. On the bottom, we'd have 997. And 2004 divided by 997 is bigger than 2. See what I'm saying there? Okay. So this is going to be like 2.1. It's not even quite that much, but it's something bigger than 2. That's why I know it's coming from the top. Okay. At negative infinity, it's going to be the same thing. I can't necessarily use negative infinity because they're not going to 0, so it can't just go positives and negatives. So let's go with like negative 1,000. If I put negative 1,000 in there, I've got negative 2,000 plus 4 is negative 1,996. Negative 1,000 minus 3 is negative 1,003. And that is going to be less than 2. That's going to end up being like 1.9. Okay? So therefore, this one is going to come from the bottom. Okay? So when you're going to 0, we can just look at positive negativeness of it. When we're not, we just got to try a number like 1,000. Okay? You wouldn't have to do anything. I mean, if you want to get bigger numbers than that, you can, but you don't have to. 1,000 works. That's pretty far away. Okay? Then we've got asymptotal behavior. As x approaches 3 from the left, what's my function doing? And as x approaches 3 from the right, what's my function doing? Okay. So left of 3. left of 3, that's going to be like 2.9. Okay? 2.9 times 2 is going to be positive, plus 4, still going to be positive. 2.9 minus 3, that's going to be negative. So this one is going to go to negative infinity. Yep, just for x. Plug in the 2.9.
Mhm.
And here, we can go positives and negatives. Because the closer we get to 3, the smaller that bottom, the denominator is going to be. Okay? And then let's go with 3.1, because that's on the right side of 3. Positive times 2 is positive, plus 4 is still positive. 3.1 minus 3 is positive 0.1. So this one would go to positive infinity. Positive divided by opposite. And there's all our answers. Okay. So as of right now, you can do number 3 on the worksheet for this week. So you can do 1, 2, and 3. Should have had 1 and 2 done already. Okay? But yeah, so we're doing like 1 problem a day kind of a thing. Okay? Thanks for playing along.